In networking, three number systems get utilized: decimal, binary, and hexadecimal. I've already covered decimal and binary numbers in my previous lessons. In this lesson, I'm going to focus on hexadecimal numbers. I'll begin with the comparison of the three. Then I will show how do decimal 0 to 15 map to their equivalent hexadecimal values. Then explain why we need 4 binary digits to represent each hexadecimal number. And then finally conclude by giving the use cases for hex numbers. To quickly recap, binary number system is base 2 and has numbers 0 and 1. Decimal number system is a base 10 number system with important numbers 0 to 9. On a similar pattern, hexadecimal number system is a base 16 number system represented by numbers 0 to 9 and letters A to F, a total of 16. Now, if I have to do a representation in a tabular format where I show decimal 0 to 15 mapping to their corresponding hexadecimal values, we can observe that the first 10 that are 0 to 9 have exact one-on-one mapping. Nothing changes. They are exactly the same. It is the numbers 10 to 15 that become interesting and get mapped to A to F. So 10 maps to A, 11 to B, 12 to C, 13 to D, 14 to E, and 15 to F. And why do we need 4 binary digits to represent each hexadecimal number? Well, hexadecimal number system is a base 16. That is, it has 16 values. On the contrary, the binary number system is a base 2 system with numbers 0 and 1. Now, it is pretty easy to understand. With one binary digit, we get two values. 0 and 1. With two binary digits, we get 4 values. With 3, we get 8. And finally, with 4 bits, we get 16 values. 16 values, remember, right? Hexadecimal covers 16 values, 0 to 9 and A to F. We need 16 values. So, 16 values can be represented by 4 binary digits. That's what it is. Now, if I represent all the three number systems in a tabular format together, showing numbers 0 to 15 and the equivalent binary in hexadecimal, we can see that each hexadecimal number is being derived by utilizing 4 binary digits. Now pay special attention to number F, which has binary equivalent of 4 ones. This is going to be discussed in detail when we go on the topic of MAC addresses and in particular talk about broadcast MAC addresses. And finally to the use cases of hex. Where do we use hex? Anytime we have to represent a long binary number in a short and easy way, we use hex numbers. The two examples in networking are in MAC addresses and IPv6 addresses. For now, remember MAC addresses and IPv6 addresses. These are topics that I am going to cover in my subsequent lessons. Okay. Finally, on the summary of hexadecimal numbers, they are base 16 represented by 0 to 9 and A to F, and 4 binary digits are used for representing each hexadecimal value, and the use case for them are MAC addresses and IPv6 addresses.